Hello student, I am Dr. Yogesh Nana Indulkar, Assistant Professor in Chemistry. Now, in this lecture, we will learn the concept from the physical chemistry, that is Bohr Atomic Model. So, this model is crucial to learn the atomic structure, and it is used for quantum mechanics. So, let's start. So, we know this model is based on the hydrogen atom, and this model is first proposed by Niels Bohr in 1913. So, according to Niels Bohr, he includes some features for the modern quantum theory in the classical theory. So, he used these both theory to explain the structure of the molecules. So, for this model, he proposed initially some postulates. So, based on postulates, his theory is there. So, first of all, we will see the postulates or the assumptions of Bohr atomic model. So, we will see the first assumptions of the Bohr atomic model, that is, an atom consists of small positively charged nucleus at the center and an electron revolving around it in a certain circular orbit. So, we will see here, so say at the center you have the positive charge and the electron is revolving around it in a circular orbit. Okay? So, such orbits are called the energy levels or stationary states and having the fixed energy. So, for this first level it has the fixed energy, for this second one it has the fixed energy. So, all these levels having the fixed energy. So, these levels or these orbits are numbered as 1, 2, 3 and so on from the nucleus, and they are designated as a capital K, capital L, capital M, capital N and so on. So, this is the first assumptions of the Bohr atomic model. Okay. Then the second one, only certain orbits are allowed or certain stationary states are allowed having the angular momentum is integral multiple of h by 2 pi. So, you can't mention at any place this orbit. So, for that particular orbit, if there is angular momentum is integral multiple of h by 2 pi, then only that orbits are allowed. Okay? So, there are not continuous orbits, there orbits having the quantized then only you will get that orbit. So, we know the angular momentum is denoted by the mvr, then that equal to nh upon 2 pi. So, for the first orbit you have this one is the first orbit. So, for this first orbit value of n is equal to 1. So, mvr is equal to h upon 2 pi for the first orbit. For the second orbit n is equal to 2, that means 2 h upon 2 pi. So, 2 get cancelled out, it becomes h upon pi. So, and so on. Then here we know h is the Planck constant, and we know the value of Planck constant is 6.626 into 10 raised to minus 34 joules second. Then the third assumptions of this orbit is as long as electrons remains in a particular orbit, it does not lose or gain the energy. Suppose you have the electron here in n is equal to 2, then whatever that electron remains only that orbit. It does not go first orbit or it does not go the second orbit, as long as that electron present in that orbit. So, its energy becomes fixed, it is not go anywhere. Then the next assumptions of this theory is for stability. Okay, this is just for the stability. So, for stability, by suitable absorption or emission of the energy, electron make transition to higher state or the lower state respectively. After absorption of energy, it goes to the higher state. After emission of the energy, it goes to the lower state. Then whatever the energy going to change on that becomes delta E is equal to E2 minus E1, that is equal to H nu. So, nu is equal to E2 minus E1 by H. So, here E1 is the lower energy and E2 is the higher energy. Whatever the energy of the lower state, that becomes the E1, energy of the higher state, that becomes the E2. Okay. So, these are the assumptions of Bohr atomic model, and whatever the atomic structure he represented based on these 4 assumptions. So just keep in mind these 4 assumptions. First one is an atom consists of small positively charged nucleus at the center and electron revolving it in a circular orbit. Then we saw the second one, only those circular orbits are allowed having the angular momentum is integral multiple of h by 2 pi. Then the third one we saw, as long as electron present in a particular orbit or particular state, it does not lose or gain the energy. Then the last one we saw, for stability, electron make transition to the higher level or the lower level. Okay. Now based on this assumption, whatever the Bohr atomic model is there, so that assumption is utilized to mention or to describe the structure of atom. So if you want to describe the structure of atom means what? We are going to say the size of that atom. So for knowing the size of the atom, we have to know the radius of that atom. Okay? So we are going to use this model to determine the radius of the Bohr atom. Clear? So we are going to just derive the equation which shows the radius of the Bohr atom. So just we are going to start here. So what we consider the system? Consider an atom consists of the nucleus. Okay, so here nucleus having the charge plus Ze and the mass is the capital M, then the electron of charge minus E which moving around the nucleus. Okay, so here M is greater, much greater than, that is capital M is much more greater than the small m, because capital M is the mass of the nucleus and small m is the mass of electron. So because of that you can consider M becomes the stationary and only the electron is revolving around it. Okay. So as per this assumption, what we are going to see here, the whatever the velocity of that electron becomes the v, and that electron moving in the orbit, for that orbit the radius becomes the small r. Okay. If you know the r, then you can find out the size of that atom. Okay. Okay. So we got the system. So this is the system. So for this particular system, if you consider the electrostatic force of attraction, because we know at the center positive charge, at or electron which is revolving around that one, it has the negative charge. So for that we have the electrostatic force of attraction, because different charges are there. Now this force of attraction becomes minus Ze square upon r square. We know these things. Okay. According to electrostatic force of attraction for this system, it is minus Ze square upon r square. Now keep in mind that these ones in CGS unit only. We are not going to use here the SI unit. Okay. So we have Fa, that is electrostatic force of attraction, is equal to minus Ze square upon r square. That is the equation number 1. Now for this system, what is the centrifugal force? So this force is the repulsion force. Okay. So when the electron comes towards the nucleus, then that electrons is going to apply this repulsive force. So that's why the electrons are not goes into the nucleus. Okay. So this centrifugal force for this system becomes mv square upon r. So we have that system. So for that system we have the centrifugal force, that is the repulsion force, and that becomes mv square upon r. So now we have the two forces, one is the electrostatic force and another one is the centrifugal force. So electrostatic force, that is the attraction force, and centrifugal force is the repulsion force. Now we know, according to Bohr model, electron revolving in a particular orbits only. Okay, it not goes to the nucleus because of positive and negative charge attracts. Okay, it's not happens like that one, as well as that electron is not go away from that orbit. Okay, if electron comes toward the nucleus, then centrifugal force acts on that, so it is going to repel. If that electron goes away from the orbit, then electrostatic force of attraction is acts and electrons comes toward in that orbits only. So for that purpose, what will happen, these two forces, that is centrifugal force of attraction and the electrostatic force, that should have the equal magnitude and opposite sign. Okay. So these two forces becomes equal. Okay. Then only we can say the electron moving in that particular orbit only. So for that purpose, these two forces having equal magnitude and opposite in sign. So we are going to take Fa, that is electrostatic force of attraction, is equal to minus Fc. Equal magnitude, opposite sign. Okay. Now put that equation 1 and equation 2 in here. So we have the Ze square upon R square is equal to mv square upon R. Okay. Now I am just rearranging this equation in terms of the V square. Okay. So this equation in V square is equal to Ze square upon mr. Now as angular momentum is quantized, we know the assumption of the Bohr model. According to that, mvr is equal to nh upon 2 pi. So I am also writing this equation in the form of V. So this is the equation, V is equal to nh upon 2 pi mr, and I am just squaring this equation. So I will get V square is equal to n square h square upon 4 pi square m square r square. Now we have the equation 4 and equation 5. So both equation for the V square, right? So this equation becomes equal. So equation 4 and equation 5 are equal on both, on left side of here, both are the V square. Now if you take that one is equal, you have this thing, that is n square h square upon 4 pi square m square r square is equal to Z square upon mr. Now again you have to rearrange that equation. What you will get? That equation you will get in terms of the r. Now that equation becomes n square h square upon 4 pi square m Z square. Okay. So this is the equation we derive for to determine the radius of that particular orbit, right, where n is equal to 1, 2, 3 and so on. If you want the radius of the first orbit, you have to take n is equal to 1. If you want the radius of the second orbit, you have to take n is equal to 2. Okay. So n is equal to 1, the radius of the first orbit, and we know for the hydrogen atom there is only one electron is there. Now if there is only one electron is there, that means hydrogen, whatever the electron, that revolving in the first orbit only. If you know the radius of the first orbit for the hydrogen, then you can find out, or you can say this is the radius of that first orbit and the size of that hydrogen. Okay. So we know the hydrogen atom radius is 0.529 angstrom unit. Now we have to just check, is it the same we are getting from this equation. Okay. So for that we are going to take the exercise. So first one, calculate the radius of K shell of hydrogen atom. Now for this one, what we have to take? We know the K shell. K shell means the first orbit. Already we saw in the assumptions that is designated as a KLMN from the nucleus. So for that we have H is equal to 6.62 into 10 raised to minus 27 earth second. Already I told that whatever the equation is basically derived in CGS units only. So you have the value of H is here, then here the mass of hydrogen, that is 9.11 into 10 raised to minus 28 gram, that is in CGS units. Then we have value of E, that is the electric charge or charge, that is 4.80 into 10 raised to minus 10 electrostatic unit. Now what is the solution for this one? So for hydrogen atom we know Z is equal to 1. Z is the atomic number basically, is 1, and for the K shell, that means again you can say the N is equal to 1. So what we have to find out? We have to find out the radius of that first orbit, that is R1. Okay. What we know? So we have this generalized equation, that is Rn, that means the radius of nth orbit is equal to n square h square upon 4 pi square m Z E square. Now for first orbit, okay, K shell means the first orbit. So we have to take R1 is equal to h square divided by 4 pi square m E square. Okay, Z is equal to 1, that's why I am not considering here. Now by substituting the value of h, m, e and pi in this equation, what we will get? Just substitute all these parameter by its values. So we have R1 is equal to 6.626 into 10 raised to minus 27. So h square is there, so you have to take the square of that one divided by 4 into 3.14 square, that is the pi square. Then you have to take the mass of electron 9.11 into 10 raised to minus 28 into, again you have to multiply by square of E, that is 4.80 into 10 raised to minus 10 raised to 2. If you solve this one, you will get the answer is R1 is equal to 0.529 angstrom unit. Clear? So already from this one, we have the value of first orbit is this one, and already I told that for the hydrogen we have the atomic size or the radius of that one is 0.53 angstrom unit or 529 angstrom unit. Okay. The second exercise is here, calculate the radius of second orbit of the hydrogen atom. Now if you want to find out the radius of the second orbit, what we have to take? We have to take remaining terms are the same. Okay, we know the value of H, we know the value of, this is the value of M, we know the value of E. Then for second orbit, you have to take N is equal to 2 and you have to find out R2. If you put that value in this equation, if you solve that one, you will get the value is 2.12 angstrom unit. Okay, for simplicity, if you see this equation and the previous equation, if you see this equation and previous equation, that is for the R1, then you can generalize that one, that Rn is equal to here n square R1. Okay. If you have this equation, then that equation you just modify like this one, that is Rn is equal to n square R1. Then you have, if you know the value of R1, then you can find out the radius of any orbit. Clear? So if you just solve that one, that is 2 square into radius of the first orbit, you will get 2.12 angstrom unit. So that's it about here. Thank you very much.